Hello, I am Mrs. Nadgouda, lecturer, Department of Chemistry, KLS Gokte PU College of Commerce and Science, Belagavi. In continuation with unit number 1, this is lecture number 8, some basic concepts of chemistry. In last class, we have seen how to solve the empirical formula and molecular formula problems, right? When the percentage composition of each and every element is given in that compound, right? So here is one more exercise for you people, and you just try to solve it. If you have any doubts, you can come and ask in the office or refer any textbook or any reference books, okay, by the same method which is already given. Now today we are going to learn the new thing, that is stoichiometry and stoichiometric calculation. See, many of you have done the balancing of chemical equation, right, in your school, and it is very difficult to you people, I know it is, right? So the number when you are writing in the balancing, right, that is nothing but the stoichiometry. Okay, so stoichiometry is the word obtained from Greek word. Stoichion means element and metron means measure. So measurement of element. Now this is in terms of atoms or in terms of molecules or in terms of mass or in terms of, very simple, is mole. Okay, so this gives the idea how much mole of any element is required as a reactant, or how much mole of product is formed during the reaction. Okay, so for these calculation, first of all, what is the condition? We have to balance the equation. Okay, and what is mean by balancing? That is, both sides the number of elements should be same. Then we say the equation is balanced. Okay, so here you can pronounce the word stoichiometry or stoichiometry. It is left to you. Okay, so let us have one example. The chemical balanced chemical equation. See, reaction is different and equation is different. Okay, reaction is nothing but the process which takes place when we mix the reactants. Okay, then equation means it's a symbolic form of the reactants and products, which is written in terms of molecular formulae. Okay, so here is the example. Methane gas, when reacts with oxygen, it gives carbon dioxide and water molecule. Any hydrocarbon, let it be methane, ethane, propane, butane, or ethene, propene, or ethine, whatever is the hydrocarbon, always when it is burnt in presence of oxygen, whenever it is heated in presence of oxygen, it gives the product, that is carbon dioxide and water. Okay, the best example is wood. A piece of wood, when we burn it in presence of air, it gives the smoke, that is nothing but the carbon dioxide, and along with that some amount of moisture. Okay, now when we write this in the form of formulae, that is methane is written as CH4, it is in bracket, it is written as gas, G stands for gas. Okay, then O2 is nothing but oxygen, gas, then CO2 is gas, and water molecule is also in the form of steam, therefore it is written as gas. Okay, so here in between the arrow is given. Okay, according to law of mass of conservation, actually both sides the amount must be same, or the number of elements must be same. So before the arrow what we write is reactant, and after the arrow what we write is called as product. Okay, now when we balance the equation, means what we are doing, the elements on the reactant side must be exactly equal to the elements on the right hand side. Okay, so this is a brief representation of chemical reaction, means the process is expressed in symbolic form. Okay. Then physical state of the reactant and product is written in bracket as like this: solid, liquid and gas. Now here, to balance this equation, we have taken 2O2, okay, and here 2H2O, right? Now you can just go through this. One carbon atom is on reactant side, one carbon atom is on product side. How many hydrogen are there? 4 hydrogens. So to make it 4, here we have to multiply 2 by 2. So 2 2s are 4 hydrogen. Then here how many oxygen atoms are there? So here it will be 2 oxygen. Then in CO2 2 oxygen. So total 4 oxygen. To make it 4 oxygen, we have to multiply by 2 to this oxygen in the reactant. Okay. So this is called as balancing. Now the coefficients, that is number, which we have written for oxygen and water molecule, are called as trichometric coefficients, which represents the number of molecules or the number of atoms for single element, or in short it is number of moles that take part in the reaction or formed in the reaction. Okay. So for when we are calculating the stoichiometry, then it is important to balance the equation. Now this balancing is done by various methods, and out of that, one common method is hit and trial method. Means just by writing the number, we can see on both sides. Just trial, as a trial. Okay. There are two other methods, that is redox reaction method or ion electron method. Okay. So that we will learn in another topic. But here, whatever reactions are given, whatever equations are given to you, you have to balance it by using hit and trial method. Okay. So this is the exercise. Try it yourself, how to balance. Okay. Then the most important in stoichiometry is we can convert the number of moles into mass, or mass into number of moles, or even we can convert the number of particles into moles, or vice versa. Okay. Even volume can be converted into moles, and that's why mole is a very easy concept to understand, whether it is whatever may be the state of the reactant or product, means physical state, though it is solid, liquid or gas. Okay. Instead of considering mass, particles, volumes, etc., we can directly consider the moles, and these all are interconvertible, and how to convert is given in this chart. Okay. So here one example, the direction is given as one way, means from left hand side to right hand side. Okay. Now mass can be converted into moles just by dividing with molar mass. Okay. And the same number of moles, if we multiply with molar mass, we will get mass of that substance. Okay. Similarly, particles, if number of particles are given, if we divide by Avogadro's number, that is 6.022 into 10 to the power 23, we will get the number of moles. Okay. If we multiply, we will get the particles. Then volume, if it is given at STP, if we divide by 22.4 liter, then we will get the number of moles of that gas, or that volume is converted into number of moles. Okay. So this is how we have to read this, and we can utilize this to convert the given quantity, and based on this we will solve some problems. Okay. So this is the shortcut for remembering how to convert, means these quantities are interconvertible. Okay. Here is one more. Number of particles are converted into number of moles. So here the way is given: divide by Avogadro number, or to convert moles into particles, we have to multiply by Avogadro number. Similarly, mass in gram. So number of moles multiply by molar mass will give you mass in gram, or if mass in gram is given, if we divide by molar mass, we will get number of moles. Okay. Then one more is given. You can go through this. See here. particles. Again the same thing is given, just in different pictorial manner it is given. So these are the shortcuts to remember. Okay. Now here is exercise given. Calculate the number of atoms or molecules in. Total 4 questions are there. Out of that, 1 I have solved here. The remaining 3 you can try it yourself. Okay. So first one, 0.4 gram of carbon is given. Means mass is given of carbon. Right. To find out the number of atoms or molecules, what is the formula? Given mass in gram divided by atomic mass or molecular mass, means this ratio will give you number of moles. See here, this ratio will give you number of moles. Now number of moles into Avogadro number will give you the number of atoms or molecules. Okay. So now the mass is given as 0.4, atomic mass of carbon is 12 into 6.022 into 10 to the power 23. The answer is 2.0076 into 10 to the power 23. This is how you can solve the remaining one. Atomic masses of respective elements are given. Okay. Then here 0.2 mole is given, 0.2 mole atoms of given, means number of moles are directly given. No question of which element is given. Okay, because number of moles into Avogadro number will give you number of atoms or molecules. Try the remaining problems. Then one more type. Calculate the mass of the following. 1 atom of potassium. See, if we go to market and if we buy 60 rupees dozen apple, okay, then what is the cost of one apple? What we do? 60. 1 dozen means 12. So 60 divided by 12, we will get the cost of one apple. Like that, if we know the atomic mass of that element divided by Avogadro number, then it is the mass of one atom or one molecule. Okay. So what is required? Gram atomic mass or molecular mass divided by Avogadro number will give you the mass of one atom or one molecule, whatever may be the element or whatever may be the substance. Okay. So here again first problem I have solved. Now 1 atom of potassium is asked. Atomic mass of potassium is 39.1 gram, which is given. Okay. So here atomic mass divided by Avogadro number will give you the value of 1 atom or 1. Now if it is molecule, where it is molecule? Third and fourth is a molecule. So here you have to find out the molecular mass, and already you know how to find out the molecular mass. I hope you remember it. Okay. Let us see for H2SO4 how to find out the molecular mass. How many atoms are there of hydrogen? 2. Atomic mass of one hydrogen is 1. So 2 into 1 is 2, plus atomic mass of sulfur is 32 into 1. Right. So this is 32, plus atomic mass of oxygen is 16. How many are there? 4 are there. So total will be 64. Now this total is nothing but what? Gram molecular mass. Okay. 2 plus 2 plus 4 plus is 8. 3 plus 6 is 9. So 98 gram is the molecular mass of H2SO4. Right. So if we know the molecular mass of this, you divide by Avogadro number, you will find out the mass of one molecule of H2SO4. Okay. So in red color I have given you the formula also. Okay. Now here atomic mass of sulfur is 32. Okay. One more type of problem, that is calculate the number of moles in 12 gram of nitrogen. So mass is given. Now you have to convert it into number of moles. So mass divided by atomic mass or molecular mass. If it is single element, we have to take atomic mass. If it is molecule, means like N2 is a molecule now. So for this is molecular mass is considered. Now atomic mass of nitrogen is 14. So N2 will be 28. Now here instead of atomic mass we have to consider molecular mass. Okay. So this is how given mass in gram divided by atomic mass or molecular mass. By using this formula we can calculate, or else number of moles can be calculated as if the molecules are given. Number of molecules divided by Avogadro number. Okay, or number of moles. For given volume, how we can write given volume of gas in decimeter cube or liter. In one more class, I have already told you that liter and decimeter cube both are same quantities. Like that, centimeter cube and ml are same. Okay. So what is the standard volume of any gas? 22.4 decimeter cube or liter. So if we divide by this number, we will come to know what is the number of moles. Okay. Already the chart I have given to you how to convert the mass into moles or moles into mass. Okay. You can use that also, or you can use this formula also, and better to write the formula in one notebook or in one paper. Okay, so that it will be helpful to solve the problems. Next one. This is one more type of problem. Calculate the number of atoms of oxygen present in 120 gram of Na2CO3, sodium carbonate. Now how we can solve this problem? See here, what is given? 120 gram of Na2CO3 is given, means mass of Na2CO3 is given. What we have to calculate? Number of atoms of oxygen only. How many are there? Okay, number of atoms means particles, total number of particles of oxygen. Okay, so here three steps are there. First you have to calculate the formula mass of Na2CO3. Just like molecular mass, we have to calculate the formula mass. Atomic mass of sodium is 23 into how many sodium atoms are there in this? 2. So 23 into 2, that is equal to 46. Okay, plus carbon, atomic mass of carbon is 12. 12 into 1, that is 12, plus atomic mass of one oxygen is 16. So total 3. 16 3s are 48. If we do the total of this, it will come as 106 gram. Okay. So this is called as formula mass of Na2CO3. Now second step, to calculate the total mass of oxygen present in 120 gram of Na2CO3. Means first we have to find out the mass, total mass of oxygen in 120 gram of Na2CO3. Now here 106 gram of Na2CO3 contains how many atoms of oxygen? 3. So 3 means 16 3s are 48 gram of oxygen. 16 3s are 48 gram of oxygen. Okay. Therefore, 120 gram of Na2CO3 will contain how much? That is 120 into 48 divided by 106, and this will come as 54.34 gram. Okay. Now to convert mass into atoms, which formula we can utilize? Mass into number of atoms. Means first we have to calculate the number of moles into Avogadro number. This will give you the number of atoms. Okay. So number of moles we can calculate by using given mass in gram divided by gram atomic mass or molecular mass. Now here we have to consider the atomic mass. Why? Because we are calculating only for oxygen, single oxygen. Okay. So and oxygen, atomic mass of oxygen is 16. So 54.34 divided by 16. will give you the number of moles of oxygen into Avogadro number will give you the number of atoms of oxygen. Okay. Again, one more method is there to solve such type of problem. Now in this, which three steps we have followed? First we have calculated the formula mass, that is molecular mass of Na2CO3. Okay. Then we have converted the oxygen, how much oxygen mass is present in that, 120 gram, and then mass is converted into number of atoms. Okay. Or else one more method. First step is same to calculate the formula mass of Na2CO3. Second is we have to calculate the number of moles of Na2CO3. So how will you find out? Number of moles is equal to given mass in gram divided by formula mass in gram. Okay. So given mass is 120 gram divided by 106. This is the formula mass. So total number of mole is 1.132 mole of Na2CO3. Now in these 1.132 mole, how many oxygen moles are there? Okay, that we have to find out in third step. So to calculate the number of moles of oxygen present in 1.132 mole of Na2CO3. Now here, when we consider this Na2CO3, given Na2CO3, this is one number, okay, means 1 mole of Na2CO3 contains how many oxygen atoms are there? 3, means 3 moles of oxygens are present in this. Then 1.132 mole of Na2CO3 will contain how much? 1.132 into 3, that is equal to 3.396 mole of oxygen. Now this number of mole are converted into number of atoms. Again the same number of moles into Avogadro number. So 3.396 into Avogadro number, that is 6.022 into 10 to the power 23. Which is again the same answer, 20.45 into 10 to the power 23 number of atoms. This is very important to write the unit, either atoms or molecules, whichever is asked. Okay. So again go through these two different types of two different methods to solve the problem. Okay. Whichever you feel easy, you can do that. Now one more I'll give. Calculate the number of water in gram produced by the combustion of 16 gram of methane. Now what is given? Calculate the amount of water in gram, means mass of water we have to find out. Produced by combustion of, combustion means burning in presence of air, 16 gram of methane. So methane formula is given. We know methane is hydrocarbon. And as I told you, any hydrocarbon when it is burnt in presence of air, it always gives CO2 and water. So first we have to write the equation. Then we have to balance it. And to balance, already we have seen how to balance this equation, right? Now according to this, we will get 2 oxygen and 2 water molecule. If you see this equation now, 1, nothing is there means what? 1 mole of methane. If we talk in terms of moles, okay, then nothing is there means 1 mole of methane reacts with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 mole of water molecule. Means 1 mole of methane produces how many mole of water? 2 mole of water. If we know this mole conversion, we can convert the number of moles into mass. How can we convert? Number of moles into molecular mass will give you what? The total mass. Okay. So 1 mole of water is nothing but 18 gram. It is nothing but the molecular mass of water. Okay. Now how it is 18? Because 2 hydrogen and 1 oxygen. 2 into 1. Atomic mass of hydrogen is 1. Therefore total 2. 1 oxygen. What is atomic mass of oxygen? Is 16. So 16 plus 2, that is equal to 18. Hence 18 gram of water is nothing but what? 1 mole of water. Okay, in terms of gram. Then mass of 2 mole of water will be how much? 2 into 18, that is equal to 36. Okay, so such easy problems will be asked. Please go through the problems once again, and whatever exercise I have given to you, try to solve it. Okay, if you have any doubt, you can come and ask. And we'll stop it here. Thank you.